Okay, so now we are going to move to the next chapter, current electricity. Current electricity. Okay, so the first question is that if there is a conductor and let us say you keep a external field, electric field, some field you are keeping, external field. So this is one case, this is electrostatics. Electrostatics. Electrostatics means when you are applying electric field and there is a conductor, but there won't be any current in this. But now when you, and also you know that there is no electric field inside the conductor, inside field is zero. Okay. Another case is current electricity, and suppose there is a conductor. Now this conductor is connected with a battery. Conductor is connected with a battery or a cell. Battery has a voltage V. Now battery will provide a electric field or a constant potential difference. So because of this, there is electric field lines existing inside the conductor. So this is a new thing, that electric field line can exist inside the conductor, but here electric field lines only exist outside the conductor. So why it happens like this in case when you connect a conductor with a battery? This is current electricity, right? It is electrodynamics, you can say. This is electrodynamics. This is electrostatics. So difference is clear. Here charges are not moving, but here charges are moving, right? And why charges do not move in this and why charges are moving in this, that also we have to understand. So first you need to understand this conductor is not connected with anything. This conductor is an isolated conductor and you have applied external electric field. So what happens, this due to this electric field polarization happens. So the negative charge move opposite of field, so negative charges start accumulating this side and positive charges start accumulating this side. Okay, this is what is polarization. Actually the electrons move from this side to that side, so because electron moves from here it becomes positive charge and electron comes here, so it becomes negative charge, right? So it is the flow of electron only happens, but due to external field this polarization happens. Now what happens, that this induced charges which is negative this side and positive this side, this creates a electric field. This creates a electric field that is called induced electric field. Induced electric field. And already there is a external field also. So here there is a external field also, which is E. E is the external field. So this external field and this induced field cancels out in equilibrium. So that is why this E induced, that is different. Okay, this is E induced, induced, and this is E inside, E inside. Okay, so electric field inside the conductor is zero because there are two fields. One is the external field, another is the induced field. These two fields are opposite and they cancel out. That is why net field inside is zero. This is in electrostatic condition. Charges are not moving. So why charges are not moving? Initially charges do move because initially to make this equilibrium charges move. Electron from that side move from right to left side. So right side develop positive charge, left side develop negative charge. Once this charge development is over, then charge does not move. Okay, definitely charges do move, but once charges are polarized, after that charges do not move. Once the charges flow stop, then it comes under electrostatic equilibrium. And then the electric field inside the metal, which is induced electric field and the external electric field, they cancel out and inside field becomes zero. That's what we have studied in electrostatics, right? We have studied in electrostatics that field inside a metal, a conductor is zero. Also note that if this is not a metal, if this is not a conductor, then the field inside this field induced is given as external field 1 minus 1 by k, where k is the dielectric constant. For metals, you know, dielectric constant is infinity, right? And you may put a minus sign here to show that the field induced is opposite of this. Okay, minus sign shows that induced field is opposite of external field. 1 minus 1 by k, if metal it is, then k become infinity, 1 by infinity 0, so only 1 will be there. So induced field is equal to minus of opposite of external field. So if it is a metal or conductor, then induced field is exactly equal to external field and opposite of external field. That's why these two fields cancel out and inside field becomes 0, right? That's what happened. But now what happens when we apply a battery? That means you are connecting the two ends. You are connecting the two ends. And by connecting the two ends, you are completing a circuit. First of all, here note that the two ends are not connected. Although this has got some charge, this has got some charge, but the charges cannot flow because circuit is not there. But here circuit is there. Because of this circuit, the charges which have accumulated that side will start flowing in this circuit. And this flow of the charges in a closed circuit, that is what it is, current. In open circuit, current will not flow. In open circuit, from current, where it will go? It cannot go. But in a closed circuit, current or charges, actually current doesn't flow, charge flows basically, right? But in common language, we say current flows, but technically that is not the correct word. Charges flow, right? So charges are flowing continuously, it is flowing because we have connected a battery. Okay, suppose positive charges flow, so positive charges are flowing from here, it goes to that side, again come here, like this it is happening. Okay, or you may say negative charges flow like this way, is going from negative terminal to positive terminal. And note that inside the battery also charges has to flow, so charges have to continuously flow everywhere. Okay, so charges has to flow in this metal or conductor, and charges also have to flow through the battery. So of course battery will also give some resistance, right? Battery has some chemicals, some salt solutions are there, electrolytes are there. So inside the electrolyte the ions are moving. Inside the electrolyte ions are moving, but in the metal ions do not move. The free electrons are moving inside a metal, right? So that's the difference. But charge flow means anything can move, either ions can move or electrons can move, but in a metal or conductor only free electrons move. But in ionic solutions ions can also move, like sodium ion Na plus Cl minus, they can also move. That kind of some reaction happens in the battery, and because of which charges are flowing inside the battery also, right? But separately you will be studying that cell, electrolytic cell and other things, not in much detail because that is in chemistry mostly, right? In physics it doesn't have. So current is flowing here and there is a field inside that. Okay, so the field inside there, field inside is not zero. Okay, but here field inside is zero, field inside is zero, inside field is zero. Why field inside zero? Because the induced and external field cancels out each other completely inside a metal. Right. Clear? Are you clear? So questions they will come. Reasoning based question comes. Does electric field, can electric field exist inside a metal? Yes and no. Both answer are possible. No, because it is in electrostatic condition. Yes, because it is in electrodynamics condition. Okay. So if charges are moving and battery is connected, there can be field inside the metal. But if charges are not moving, battery is not connected, so field inside will be zero. Right. These things are there. Okay, so once we are clear with this, then let us understand further about what is electric current. What is an electric current. It is the flow of charges. It is the rate of flow of charges. It is the rate of flow of charges through a conductor. So suppose there is a conductor and you have connected a battery plus minus. So what happens is that the charges are flowing. Basically electrons flow because electrons are there, lot of electrons are there inside the metal. So these electrons start flowing towards the positive terminal of the battery. These electrons start flowing towards the positive terminal. Okay, so because of this flow of electron, rate of flow of this charges, that is what is current. So current I can be defined as dq by dt, rate of flow of charges. Also note that the direction of current is the direction of flow of positive charges. So the direction of current is based on positive charges. So electron is flowing this way. Current has to be due to positive charges. So positive terminal will supply positive charges. So you can imagine that positive charges are flowing like this way. So this is the direction of current. Current direction is towards left to right. That is what we have to understand. Current direction is from left to right. But electrons are flowing in opposite direction. Electron flows from right to left. Okay, so electron direction and current direction is different, opposite, right? But the rate of flow of charge dq by dt, that is what it is. So in NCERT there is a mistake there, while they are giving the concept of the current, there is a mistake there. I will explain that mistake with the example. Suppose there is a cross section area. Let us consider this cross section area of a metal. So through this cross section area, let us say plus 2 coulomb charge is moving this way and minus 2 coulomb charge is moving right this way. Plus 2 coulomb and minus 2 coulomb charges are moving, and these charges are flowing in, let us say, 10 seconds. I'm just giving a rough example that these charges plus 2 coulomb and minus 2 coulomb are crossing over this area in 10 seconds. What is the current? If they ask what is the current? Current how to come? Now here note that you can choose one direction as positive and another direction as negative. Although current is not a vector quantity. Current is not a vector quantity, but the direction we have to indicate. Okay, so suppose positive charges are going in this direction, positive direction. This direction let us choose as positive, and this direction let us choose as negative. Okay, two direction we are choosing here. One is left to right is positive, right to left is negative. So in the positive direction, if positive charges flow, that makes positive current. Okay, so positive charges plus 2 is flowing in positive direction. So charge is plus 2 and time is 2 seconds, and time is 10 seconds. Charge by time. Now this is making positive current. What about negative charge? Negative charge flowing in negative direction also makes positive. Okay, so note that negative charge minus 2 in negative direction. We are putting a minus 1 for direction. Okay, if you want you can multiply plus here for direction. So positive charge multiply with positive direction divided by time that is current. Negative charge multiplied by negative direction divided by time. Time is also 10, right? In the same 10 second, this is happening. So in the same 10 second, both the charges are flowing. Okay. So you are calculating the total current, or you can say this is called average current. Average. Why average? Because you are calculating over a interval of time. Over a interval of time. If you calculate instantaneous, that is differentiation, right? But over a interval of time, you are taking a time interval 10 seconds. So in this 10 second, plus 2 coulomb flows in positive direction. So plus is multiplied because positive charge multiplied positive direction. Negative charge multiplied with negative direction also gives positive. So totally if you calculate, it become here 2 and 2 4 by 10, that becomes 0.4 ampere. Ampere is the unit. Okay. So a current of zero point 0.4, this is how we calculate. So positive charge into positive direction, right? So that means you multiply charge with direction. That will actually give the current. Okay. So divided by time, of course. So charge multiplied by direction, charge multiplied by direction, like that. Clear? Okay. This is how we'll calculate the current. This is average current, right? So current is coming positive. Sometimes current may come negative also. So here positive means current is flowing from left to right, and if it is negative, then current is flowing from right to left. So positive negative doesn't mean it's a factor. Why? Because it will give direction, right? Because current has direction, but current cannot be added like factors. Okay, the addition of current is just like a scalars, so it is considered as a scalar quantity because it does not follow the laws of factor addition. Okay, that's why current is a scalar quantity, right? Okay, this is the idea behind current. Now let us take some example here from based on this formula. I is equal to dq by dt. We can write, this is one formula. So suppose if I draw the graph of charge flowing versus time, charge flowing versus time. So let us take one example. Suppose there is a cross section area of a conductor. Through this cross section area, some charges are flowing, right? These charges depends on time as 2t square minus 3t. Okay, like this. Now the question is find current at time 1 second. Find current at time 1 second. So here definitely current calculation you can do by differentiating. I is equal to dq by dt. Differentiate. So 2t square differentiation 2t minus 3t differentiation 1. So 4t minus 3. And time 1 second they are asking. So 4 into 1 minus 3. So you will get 1 ampere. So the current which is flowing, or current at 1 second in this wire, is 1 ampere. Clear? Like this type of questions you can solve. But sometime in need based question they can give graph. Let us say there is a graph given like this. Okay. And they ask what is the current. They may give you this angle. Let us say angle is 45 degree. Find the current from this graph, and charge is in coulomb, time is in second. Find I. Tell me what will be the value of current. Why area? Tell me why area? Hmm? What is current? No, dq by dt. Q by t is like average, instantaneous. Okay, dq by dt. So tell me, dq by dt means what in a graph? Qt graph is there. What is dq by dt means? Hmm. What is dq by dt? Hmm. Tell me, why you have any doubts in this? dq by dt, dy by dx means what? What is meant by differentiation? Hmm? Eh, no, no, no. Area is integration. Area is integration. What is differentiation? Ah, slope. What is the slope of this line? Ah, how much is tan theta? Then that is the answer, na? So I is equal to dq by dt, which is tan theta. Here tan 45 degree. That is 1 SI unit ampere. That is the answer. Hmm. So of course here it's a straight line, so current is going to be constant because slope is constant here, so current is constant. But in sometimes the graph is different, like q by t graph is like a non-linear graph like this. Then different place slope is different. Suppose if you take this point, so the tangent here will make some angle theta. So at that particular instant of time, let us say this time is t1, at time equal to t1, current is equal to tan theta, right? But at different point, slope will change. Slope will change, so calculation will change. So current will be different. So this is a variable current. Okay. The current is changing because slope is changing, so current is not constant. I is not constant. Current changes. Okay. Now tell me, what happens? What is the current? Let us say a graph is there, Q versus T graph, and the graph is like this, sinusoidal graph, and there are three. One time is 0. Let us say this is 1 second, this is 2 second, this is 3 second, 4 second, like that it is. Charge is coulomb, time is second. Okay, and let's take the equation also. If you want to take equation, here the equation can be sinusoidal. So q is equal to, let us say, 2 sine 2 pi by 4. So time period is 4. So pi by 2t. Okay, this is the equation. Q is equal to 2 sine. Right. This is the equation. So now you calculate, find current at time 0, 1, 2, 3, 4 second. There are different time instant 0, 1, 2, 3, 4. Calculate this. So tell me the values. I will write it here. Time 0, time 1, time 2, time 3, time 4. What is the current here? Why 0? Yeah. And this logic is not correct. Logic you are saying time is 0. No. Again, what is meant by current from the charge time graph? Is the slope dy by dx or tan theta. So dy by dx definitely current is not 0, because when you draw a tangent here, when you draw a tangent, some angle will be there now, correct? Some angle will be there. Here you can say it will be 0, because here it will make it will become parallel to x axis. Here theta will be 0. Here also theta will be 0. Maxima and minima, you know now, slope is 0. dy by dx is 0. So maximum minima slope will be 0. So that means at 1 second and 3 second current will be 0. Here you don't have to calculate. But other values, and I think at 4 second and 0 second slope is going to be same, because if you see the graph here also it will make the same slope, right? I think this angle theta and this angle theta will be same, right? So whatever the value at 0 second, same will be at 4 second. And 2 second it might come opposite, but anyway you calculate now dy by dx, you know how to do now. Calculate dy by dx. So first of all, what is current? Current is dq by dt. And what is q here? Q is 2 sine pi by 2 t. Differentiation of this with respect to time. Do this. 2 is constant, it comes out. Then sine differentiation will become cos. And the coefficient comes out because of internal differentiation. Then this 2 will get cancelled. Current will come as pi into cos pi t by 2. Okay, this is what it is current. Now you can put any time and calculate. This is current. Okay, now calculate 0. Put time 0 and calculate. So when you put time 0, what happen? Cos 0 become 1, so value will be pi. So here it will be pi, ampere. Ampere is the unit. Similarly, put the value of time as 2 seconds, because 1 we don't want, because if you put 1 cos 90 degree, pi by 2 will be 0, you know that it will be 0 only. So put time 2, pi cos pi will come. So what is, how much will be current then? Cos pi is minus 1, minus pi will be current. Okay, then at 4 second, 4 when you put it, then 4 by 2 will give 2, cos 2 pi, cos 2 pi same as cos 0, cos 0 is 1, so again pi only you will get. Clear? This is what it is. Okay, so that's how we can calculate current. I have given some examples, so we can find the slope and calculate. If it is a straight line, then it will be constant. But if the graph is not a straight line, it is a non-linear graph, then current also will change, right? If they ask what is the uh, total or average current, let us say in this question, if they ask find average current from time 0 to time, let us say they give a time 4 seconds. This means one cycle, one complete cycle. One complete cycle. Okay, if they ask current in average current, so what is average current? Average current is delta q by delta t. Delta q by delta t. Delta q by delta t. So q2 minus q1 by time interval is given here 4 minus 0. Okay, so that means q2 minus q1 by 4. q2 minus q1 means how much charge has passed, how much charge has passed between that interval. How do we calculate the charge it has flown between that? Delta q or q2 minus q1 refers to what? Delta q is nothing but the total charge flown, total charge flown from time 0 to time 4 seconds. Between these two time instant or within that interval, how much charge has flown? How do we calculate? Because here in this graph, if you see, this graph is giving what? This graph is giving the instantaneous charges flowing, right? For example, at 0 second, 0 charge is flowing. 0 second, 0 charge is flowing, but still current is there, right? 0 second, 0 charge flows, but still current is there. That is maths. Okay, because maths we cannot understand. 0 second, 0 by 0 is what? 0 by 0 is there something. So, but how do we calculate within that interval? How to calculate the, because in this graph can we calculate, suppose if I say this charge q2 minus q1 means charge at 0. Charge at 0 is 0 only, no charge is flowing at 0 second, and charge at 4 second is also 0, right? So here also charge is 0, here also charge is 0, that means overall no charge has flown between them. So 0 minus 0 divided by 4, correct? Because instantaneous charge which you are counting here at 0 and here charge at 4. So charge at 0 and charge at 4 both are 0 0 only, correct? So 0 minus 0 divided by 4 will give 0. But there is another way also, we'll try to do that. So this becomes average current becomes 0 minus 0 divided by 4. That means 0 ampere. So average current is 0. Let us think in another way how to calculate average current. So basic idea is that how to calculate delta Q. How to calculate delta Q, that is the idea. So note that I is equal to dq by dt. So from here dq can be written as I dt, and then we can integrate this. Now when you integrate, this become delta Q. Delta Q is the charge flown in that interval, delta Q. This delta Q becomes equal to integration of I dt from whatever time you want, t1 to t2. Here you want 0 to 4. Let us apply this condition t1 t2. T1 is 0 here, T2 is 4 here. Let us try to calculate delta Q. So note that this is like integration, area under the graph. Okay, integration is area under the graph. So if I have a current time graph, suppose if I have current time graph, IT graph, if I have current time graph, then current time graph if I have, suppose we can draw that current time graph because it's a cos graph, amplitude is pi. So plus pi and minus pi, I think you know about cos graph, right? Cos graph looks like this way, like this, it is, okay? And time period of this graph is also same as time period of that charge graph. So here also the same 1 second, 2 second, 3 second, and this is 4 second, okay, like this. Now try to understand what is area under the graph means. Area under the graph means what? Area under the graph means this area. Current time graph, this area, right? This area is delta Q within this interval 0 to 4. So note here that this area, which you can take this area as positive. Okay, this area is going to be positive. This area is positive. This area is also positive, and this area is totally negative. Okay, and note that equal amount of areas positive and negative, they will cancel out total area when you add. So this positive and this negative, when you add all this, they will cancel out. So that is why the total area here is 0. Total area which represent delta Q is going to be 0, right? So that is how delta Q has become 0 here, right? That's the idea. Clear? Okay, so now we can note important thing that if we have QT graph, charge time graph, then the slope of this graph, slope is dq by dt. This slope represent current. Okay, and if you have current time graph, any type of graph is there. So here area under the graph, means between a time interval t1 t2, within this. So this area gives delta q, which is the integration of current with respect to time between the time interval t1 to t2. These two ideas we can use in the problems, right? So charge time graph, slope at any instant, any point, we draw a tangent. That tan theta will give dy by dx. Slope means this tan theta. that is the current. But in current time graph, the area under the graph will give charge flown. Delta Q is what? Delta Q is charge flown between that interval. Charge flown in that interval. Charge flown in that interval. Clear? Okay. Then next is drift velocity. Drift velocity of electrons. So suppose that there is a conductor. This conductor is connected with a battery of voltage V plus minus. Then what happens? The electrons. So many electrons are there. All these are negative charges. These electrons get attracted towards the positive terminal and they start moving towards the positive terminal like this. Okay. So the average velocity with which electron moves, all the electrons, so average is calculated for all the electrons. Average is not calculated for just one electron. Okay. So this idea is very important. Drift velocity of electron is the average velocity of all the electrons. Average velocity of all the electrons with which it moves towards the positive terminal of the battery when the battery is connected across a conductor. So when you connect a conductor, then the electron start moving towards the positive terminal because of force. Positive charge will attract the electrons. So this average velocity is called drift velocity. So there are so many electrons, and note that electrons are also having thermal vibrations or random motion. So each electrons can be moving in random direction here, there, all this. There, all. So each electron has random motion due to temperature. Each electron has random motion due to temperature. So each electrons are moving randomly. Suppose you do not apply battery, then each electron is moving randomly. Effectively, there is no electron flowing in the conductor. You can take any cross section. Suppose 10 electron goes from left to right. Same 10 electron can go from right to left. So effectively, there is no charge flowing in the conductor. But when you connect a battery, then charge will effectively start flowing. So this random motion remains as it is. Random motion does not change, but a additional motion happens. That additional motion is the drift velocity. That happens because of applying the battery. Okay. So because of this, electrons slowly start drifting, and note that drift velocity is not a very high speed. It is in terms of millimeter per second, and it slowly electrons starts moving. So how to calculate that? Note that as electron, let us say electron starts moving. So as the electron start moving, it may collide with the atoms also, right? So as it will collide with the atom, again its direction may change, right? But is electric force is there, electric field is there, so it will continue drifting in the same direction. Okay, momentarily or for a very small moment, it may hit with some ions, which is called lattice or atoms. It may hit it, but its direction may change. It may become random because it may hit in random direction. We do not know. Its direction of velocity may change, but again it will start drifting. Okay, so the drift velocity is an important calculation, and NCRT has given correct derivation for that. But in some books like S.C. Verma, which is a very nice book, there also some assumption have been made which is not the correct assumption. So the formula has been derived in a different manner. Okay. So let us wind up to here. Drift velocity derivation we will be seeing in the next class. Okay, so meanwhile you start working on capacitance problems, and you can start working also some basic question on current like dq by dt or area under graph. Fine. Okay, then we'll see next class. Okay, bye bye, and keep the notes in PDF format. Save it, and you can make notes from that. Fine. Okay, bye bye. Yes.